Welcome to this class. And today we'll be looking at a topic called optics. This is an aspect or a branch of physics. So optics is just talking about light generally. And what is optics? This or light, this is a form of energy that travels in a straight line and is a form of electromagnetic wave. It travels in a straight line and it is a form of electromagnetic wave. What does this mean? It means when you point your torchlight, for example, it doesn't travel backward. It moves in the direction in which you are pointing. It means that it travels in a straight line. And it usually travels in rays. So this is a ray of light. So just one of it is a ray of light. And when I have two or more of it, it is called a beam of light. So this is beam and this is ray of light. So I have a beam of light traveling parallel direction. I can also have beams of light in other forms. You can have it as diverging beams of light. So when rays of light leaves a point and travels outward, this is what diverging. They are what? Moving outward. So we call them what? Diverging beams. And when they come from that to a point, let's say rays of light are traveling this way, and they're all traveling and coming to a point. And they're coming to this point, moving in this direction. This is converging beams. So when it's just one line of light, it is called a ray of light. When you have two or more, we have to call it what? Beam of light. And this one, what we have here is what? Parallel beam. Parallel beam. So we have parallel beam of light, we have diverging beam of light, and we have what? Converging beam of light. So this just explains that light travels in a straight line. So the lines can be convergent, it can be diverging, or the lines can be parallel. But please know that light can be reflected, it can be refracted, it can be plane polarized. What does this mean? It means that if these lights are traveling, let's say this is a plane mirror. If this is a plane mirror, and I have light incidented on this plane mirror, it creates a normal. This line here is called the normal ray. This light will be reflected off this mirror. What does this mean? It means that when this light hits this plane mirror, it will bounce out of the mirror. So reflection is just the what? The bouncing away of light when what? It hits a plane surface. So light can be reflected, refracted, and focused using optical devices. Focus there means what? Plane polarized. Reflection is just the what? The redirection of light when it hits a plane surface or whenever it hits a surface. Now it can hit a plane surface, it can also hit a rough surface. So when light, let's say I have a plane surface and I have rays of light hit this plane surface, they will all move out in that same regular pattern. So when rays of light hit this plane surface, let's say this is a plane mirror, and light hits it, you discover that what? They move out sequentially, that same what? Pattern. This is called what? Regular reflection. We call it regular reflection because it is what? On a smooth surface. So we call it what? Regular reflection. We also have irregular or diffuse reflection. For example, if I have a rough surface like this and I have rays of light coming this way, so this is what we call diffuse reflection, or irregular reflection. Now we call this diffuse reflection or irregular reflection because the pattern in which the light hit the surface, they do not what reflect out of the surface using that same pattern. So it is scattered because they are hitting the surface at different angles. So we call it what diffused or irregular reflection. So whenever light hits a rough surface, they produce what scattered light, which is what diffuse reflection or irregular reflection. Please note that what the application of reflection can be seen in periscope. It can also be seen in your dressing mirrors. When you stand in front of your mirror, the reason why the mirror can give you your image back, it is because of what light that is what is incidented on it, and a picture of you is what brought out from the mirror. So that is the application of reflection. So refraction, this is the bending of light as it passes from one medium to another due to change in speed. So what does this mean? When light travels from one medium to another, it changes its speed. For example, when light travels from air to glass. So if you have, let's say I have a cup this way, and then I put a spoon into the glass. Let's say this is a glass, and I put a spoon inside the glass. Now, when you look from the top of the glass, when you look at the spoon is straight. But when you look through the glass to see the spoon, you discover that it's as though the spoon is bent. Why? Because that spoon has traveled from air to glass. So it has passed from one medium to another. So you discover that when light travels from one medium to another, there is change in the direction. So it is the bending. Refraction is just the bending of light when it passes from one medium to another. And the reason for this change is due to what? Differences in the speed. So when light travels from air to glass, the speed of light in air is different from the speed of light in glass. So the speed difference is what causes the change in the bending of light. And please note that both reflection and refraction have laws. For example, the first law of reflection says that the sine of the angle of incidence is equal to the sine of the angle of refraction. The sine of the angle of incidence is equal to the sine of the angle of reflection. That's the first law of reflection. And the second law of reflection says that the incident rate, let me explain. This is the incident rate. The incident rate, the normal rate, and the reflected ray. So this is the incident rate. This is the reflected ray. And this is the normal ray. So the second law of reflection says that the incident ray, the normal ray, and the reflected ray all lie on the same plane. That's the second law of reflection. The same way that reflection has laws, refraction also has its own law. And the first law of refraction says that the incident ray, the normal ray, this is the incident ray, this is the normal ray, and the refracted ray. This here is the refracted ray. Refracted ray. So the incident ray, the normal ray, and the refracted ray all lie on the same plane. That is the first law of refraction. While the second law of refraction says that the ratio of the sine of the angle of incidence, the ratio of the sine of the angle of incidence, which is sine I, to the sine of the angle of refraction, sine R, is a constant. So this is called Snell's law of refraction. That says the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. And that brought about what we call, this constant here, what we call refractive index. Refractive index. And that is what we call this constant here. And that is what Snell's law of refraction. So what are the effects of refraction? The first effect is that we have apparent bending of objects in water. I've explained that before. If you put a spoon inside a glass of water, you discover that what, when you look through the glass, you discover that what, the spoon is bent while it is inside the water. But if you look above the water, you discover that the spoon was straight. Why? Because it has traveled from one medium to another. We also have it as what information of rainbows and mirages. Mirage are what objects or things that appear as though they are real, but they are not. They are what usually virtual images, and that is what we call mirages. So that takes us to what we call lenses. What are lenses? We have two types of lenses. We have what is called the convex lens and the concave lens. And these lenses are used for correction of eye defects. And some of them are used for magnification of objects, like the ones you have in your periscope, the one we have in your microscope, the one we have in your telescope, and etc. So the next we're going to talk about are lenses. We have two types of lenses. We have the convex lens and the concave lens. The convex lens is a convergent lens. That means it is a lens that brings parallel rays of light to focus, to a focus point. That means it brings parallel rays of light to a point. What does this mean? If I have rays of light traveling, it is bringing them to a point. Now I will call it convex lens. So it brings parallel rays of light to a point. So if these rays are traveling, your convex lens transforms them to be in a point. So let's say I have my rays traveling this way, and I have a convex lens here. Immediately they hit this ray of light. Immediately they hit this convex lens. This is a convex lens. Immediately they hit this convex lens, you start seeing the rays travel this way. To a point. So it has immediately they hit this convex lens, they are now brought to a point. So this is what a convex lens. And your convex lens can be used in magnifying glasses. So what are magnifying glasses? These are objects or apparatus that we use in the lab for making objects larger. So you use it for viewing small objects to make them larger. You can also see them in cameras, and it is also the lens that is present in the human eye. We also have what is called the concave lens. Now your concave lens, unlike your convex lens, it spreads out objects. So if I have rays of light traveling this way, so this is a parallel beam of light, and then they hit. This is a convex lens, a concave lens. So if they hit a concave lens this way, unlike when they hit a convex lens, what they are going to do here, they are going to diverge. Here, they are going to be diverging. Unlike when they hit a convex lens. Now, when they hit a convex lens, they were brought to a point. But when they hit a concave lens, they are scattered out from a point. So at this point, this is what we call what? This here is a concave lens. And this is a convex lens. So you discover that in a convex lens, the outer part is pushing outward, but in a concave lens, it is pushing inward. Hence, the midpoint here is tinier than or less thick compared to what the edges. But here, the midpoint is thicker than the edges. So in a convex lens, the midpoint is thicker than the edges, but in a concave lens, the edges are thicker than the midpoint. And they are also used in spectacles. Your concave lens are used in spectacles to correct short-sightedness. So your concave lens are used for correcting short-sightedness, meaning that if the person can only see very closely, you use what? A concave lens. If the person can see only far objects, you use what? A convex lens. So that takes us to the lens formula. Now we have a general formula for lens, which says 1 over focal length is equals to 1 over image distance plus 1 over object distance. So F here is talking about what? Focal length. V here is image distance and U is object distance. So whenever they ask to calculate the focal length of a plane mirror or of a lens, this is the formula we use, and it's also called mirror formula. So moving on, that takes us to mirrors. Now we have different types of mirrors. We have what is called the plane mirror, we have the concave mirror, and we have the convex mirror. Yeah, your plane mirror forms upright image, although it is of the same size, but the image is always virtual. It forms what? An upright, small, same size image, but a virtual image. What does this mean? It means when you stand in front of your plane mirror and you look at yourself, you realize that what? The same size you are is what you're going to see in the mirror, but the image is not real. The image is virtual, meaning that when you lift your right hand in the mirror is not lifting its right hand, it's lifting the left hand, because the mirror is going to turn you the other way, and that is what? Laterally inverted, and that means you're not going to have what? A real image, your exact image as it ought to be. So a plane mirror forms what? An upright image. It forms a same size image, but the images are always what? Virtual or laterally inverted. So we have a concave mirror. Now your concave mirror forms real image or virtual images depending on the object distance. So the object distance is what determines the kind of image that a concave mirror will form. So they are used in headlights, or they are also used in shaving mirrors. So if you have ever been to a good barber shop, they have concave mirrors, but in some barber shop they use plane mirrors instead of what? Concave mirrors. So you see them in your headlamps. So your concave mirrors are present in headlamps so that they can what? Divert lights from the headlights. So what is called the convex mirror. Now your convex mirror always forms smaller images. They always form smaller images that are upright, and they are used as what? Vehicle side mirrors. That's why you discover that in your vehicle side mirrors, written on the mirror, you see that the right objects in this mirror are closer than they appear. Meaning that when you look inside the mirror, the objects are very small, as though they are far away, or the car that is coming behind you is appearing as though it is far away, but it is very, very close. So that's why they write it there, that objects in this mirror are closer than they appear. That is an example of a convex mirror. So that takes us to the human eye. Now, like I said before, the human eye uses what we call the convex lens. The human eye uses the convex lens, and it has many parts. The human eye has many parts. It has the cornea, it has the iris, it has the pupil, it has the retina, etc. Now, the cornea, it refracts light rays. It redirects light rays. Then we have the lens. Now, it focuses the light on the retina. So when the light travels inside your eye, it is the what? The lens that will focus it on the retina. And what does the retina do? It converts the light rays into optic nerves. Optic nerves are now what? The ones that will transfer the information to your brain for interpretation. So that's what the retina does. Now, what does the pupil and the iris do? The iris is like a finger in front of the eye, and it allows what? Light rays to travel inside the eye. It controls the entry of light. So it controls the amount of light that should enter into the eye. That's why when you walk from a dark room into a very bright room, immediately you start feeling pains in your eyes, because the amount of light that enters into your eye at that particular time is higher than should have entered your eye. So the iris or the pupil start adjusting the amount of light that will enter into your eye. Moving on. So let's talk about the defect of the eye. The first defect of the eye is myopia, or short-sightedness, and this can be corrected using concave lens. Short-sightedness. This means that this person can only see close objects, and if the object is very far, the person cannot see it, and that is what? Short-sightedness, and that is corrected using concave lens. We also have hypermyopia, which is what? Long-sightedness. It means that this person can see objects that are very far, but objects that are close, the person cannot see it, and it can be corrected using convex lens so that it can bring it to a point. We also have other defects such as astigmatism. Astigmatism, which is also what? A defect of the eye. Let's talk about optical instruments. Now, optical instruments are just one of the applications of light. We use what? Light in optical instrument. And one of the first optical instruments that we're going to talk about is the microscope. And it uses lens to magnify objects. So in your microscope, for example, you have what we call the compact microscope that combines what? Two convex lenses to what? Magnify what? Object. We also have the telescope that magnifies objects that are what? Very far. They use it in astronomy. So the telescope is used for what? Magnifying distant objects. So if you want to look at the stars and see them in their large form, what they use is the telescope. We also have cameras, like your small cameras are used for snapping pictures. They use convex lens to focus images on the film. So they focus images on the film or the sensors using convex lens. We also have what is called the periscope. This uses plane mirrors for viewing objects over obstacles. You can see examples of your periscope in submarines. So they use what? Periscope. And these are what? Some of the applications of your light waves. Moving on. So what are the key points to remember? Now, the first thing we have to know is that what? Light travels in a straight line. And we also saw that reflection obeys two fifth laws, which we call what? The laws of reflection. We also say that what? Refraction also obeys two fifth laws. The laws of refraction, which is Snell's law of refraction and the normal law of refraction. So, and it depends on what? Medium and the speed of the light rays. So we said that what? In refraction, medium is very important because it travels from one medium to another, hence there's what? Bending of the ray. And what? That bending of the ray is depending on the speed. So because there's a difference between the speed in air and the speed in glass, for example, hence there's bending of that ray of light when it travels from air to glass. And that is what? Refraction. We also talk about what? Lenses and mirror and how they form images around their different parts depending on the curvature. So the shape of the lens will determine the kind of image that will be formed. We also say that what? The human eye is an example of optical instruments and it uses convex lens. Moving on. So we talk about many different devices such as the microscope, the telescope, the cameras, and etc. Come to the end of today's class. We're going to be doing a video on questions of this topic on our channel. Make sure you subscribe to get notified.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao, NET, IALT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.